Right. Hey, we're live. What is up, everyone? How is this beautiful Saturday evening, morning, noon, whatever? Okay, let me quickly say that I'm live. I'm live. LMAX, RingBuffer with Unsafe.Pointer, yada yada yada. Tweet, and then of course. Wait, just talking to elite person right now. Can you link? We're gonna do some crazy stuff. I'm gonna show you some crazy stuff, but first of all, I need to do. Tell me everything, guys. What is up? What is going on? All good. Ivanes. How is it going? Well, it's fine. It's kind of, I don't know. It's busy for me, man. It's so fucking busy. It's crazy. But hey, it is what it is. I'm trying to be a better person each day. That's what's going on. Can you feel it? I can feel it. Mic OCD, anxiety, panic attacks. And all that stuff, but we don't care, right? We just take it like a man. It is what it is. Look at my head, man. It's blinking. It's crazy. I wish I had hair. Donate so I can do a hair transplant and be young again. So people can stop calling me the GSP or the Johnny Sins of YouTube. All right. So today, basically, I'm working... like you guys know, I'm working on Hollywood, right? Which is basically the fastest actor engine framework for sure in Golang, that's no doubt, and probably in a lot of other languages also, right? It's going to be the fastest one. Why? Because I spend a lot of time making it fast with all problems that arise, right? And I'm spending a lot of time on basically, what's the most important function? It's this one, right? If you go to engine, there's going to be the send one, right? Send is important. Why? Because we're sending messages, right? That's how actors work. You send messages. Where is my send? Here, this one, right? We can send in memory to actors in memory. We can also send over the wire, a remote. So that needs to be very fast, and each actor will have an inbox, right? An inbox. Let's open up inbox here. An inbox is an interface. We have an inbox, and this inbox has a ring buffer. What is a ring buffer? It's a ring buffer. It's a ring that buffs. A ring buffer is basically just a data structure that it's basically an array or a slice, whatever you want to call it, and it goes in a ring, right? It's a pre-allocated data structure, pre-allocated slice or array, whatever you wanna name that, because a slice underlying is an array, and you basically just circle between it. And of course, if you really want, you can make it grow. If it's that's actually most of the time ring buffers don't grow, because then it's not a ring buffer actually, to be honest. But some implementations do that. The problem, of course, is this ring buffer. First, I implemented this with channels, with Go channels. Very easy, but very slow, right? Exactly, Go channels are very, very slow. Of course, Go channels are very convenient, right? They are easy to use. You can basically, it's like you can be a retard and you cannot fuck it up because they are protected and it's all good. Test, yeah, okay. I need to be double checking that I'm not explaining everything against nobody. It's not the first time that happened. So then yeah. How are you going to solve that? You could use a ring buffer with a mutex, but the mutex is a bottleneck, right? A wise man once said to me, he said, don't ever say mutex. You don't need to think, should I? You don't need to say, should I use a mutex here? You need to say, should I use a bottleneck here? If you replace mutex with bottleneck, you're in a different programming environment, right? Should I use a bottleneck here? And no, we don't want bottlenecks. We don't want that. What is up, everyone? Johannes, Webster, Dev, and everybody. Good evening. Welcome. So I was experimenting, and I came with the LMAX. The LMAX Disruptor. It's basically coming from the LMAX exchange. It's a very fast queue, a very fast producer-consumer library written in Java. And it does some mechanics, some other mechanics to synchronize between consumers and producers. Barriers, upstream barriers, whatever you want to call it. And it's optimized. Well, it's optimized. You don't use any kind of a mutex or specific stuff. That's why it's super fast. And some guy wrote something in Golang, but it's not really working. Well, it is working, but it's not thread safe. So I basically implemented my own LMAX version because, hey, if somebody can please give me, like I said, if you want to use advanced stuff, most of the time it's not out. Nobody has done it. That's a problem. So I did it myself. What's the problem with a channel as a RingBuffer implementation? It's fucking slow, right? That's a problem. I'm maybe 100 times faster. Well, that's maybe I'm a magnitude, order of a magnitude faster than channels. Way faster. Like, I'm already sipping margaritas on the beach while you're still processing your messages. That's the thing. Of course, hey, like I said, the first implementation, if you go back into the commits of Hollywood, was just a channel. There was no RingBuffer. It was basically just a channel queue, which is actually a RingBuffer if you think about that. But it grows and yada, 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 right? Atomics and Unsafe.Pointer, that is everything what's needed for a RingBuffer. Exactly. Ivan S knows his stuff, right? So I was experimenting with this, and I basically I copied a lot of stuff from that guy, of course, because, like I said, I'm not an academic, right? I'm a hacker. I know where to find things, and I implement them, and I just give him this little salt bay, my own salt. Oh, look at this. My own salt bay. Look at this bicep, man. It's crazy. It's written too many bytes. You know what I mean? All right. So, yeah. So let's open up LMAX test, right? So I'm gonna. Right. I have a sync mutex here. Look at this. Bottleneck, right? Bottleneck. Very important. Bottleneck. Don't ever say mutex. Say sync.bottleneck. You need to sync.bottleneck. That's what you need to do. Sync.bottleneck, right? All right. So first of all, let me show you some stuff, right? So let's say, so what's going to happen? How did I set this up? That's also a good thing. I set this up like this. We have, this LMAX is a, don't worry about that. We have a consumer, right? And it has a cursor, and a cursor is basically just an int64 with a padding optimizations. And the only thing we do is basically atomically store and load values, right? That's very important because a cursor is basically determining where are we in the buffer and where did we written to the buffer and where are we read? Where did we read, or whatever you say that. And this upstream is actually not needed because this upstream is basically support for if you have different multiple producer barriers, but that's too complex. I basically implemented this for a single consumer, multiple producer. It doesn't matter. Don't think about that. So we have a consumer, and a consumer basically consumes. It just does some stuff. It basically keeps reading the messages, right? And it calls consume here. It calls consume. Can you guys actually read that? Because yeah, you can. It calls consumer consume, which is basically an interface that you can pass into it, and it will give you the lower boundaries and the upper boundaries of where your data structure could be a RingBuffer of type whatever you want, right? And then you have basically a producer, which basically produces stuff. It loads some stuff atomically in, and then it does some spinning shenanigans. It's basically a gate for your sequence, and then you can commit, and basically it stores where you commit each time you push to the queue, you commit one, but you can also say I have a group of messages, so you can commit them all at once, right? I have 1,000 messages, and instead of basically looping 1,000 times and push them to the buffer, and you need to commit and atomically load and yada, 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 you can basically commit the whole shebang at once and just, boom, overwrite them, put it all in memory and just commit it, and then you have 10,000 messages instantly in your buffer. Very important. Speed. Very important for speed, very important to, for a lot of stuff. That's how I set this up, right? And I was thinking, so basically, let me show you. Let me delete this this pointer. Let me show you how it. Let me do this with a buffer, right? Let me do this with a mutex, right? So I'm gonna do it with a mutex real quick to show you the difference. Because it's very important that if you don't lock your buffer, you're gonna have race conditions. That's very important to understand. Because in my opinion, I was thinking, yeah, but the LMAX, it should actually be safe to write to. It should be safe to write the sequence because each time consume. Let me show you here. So each time you're gonna say producer reserve, and you're gonna reserve the amount of written stream, your cursor, you're gonna reserve your cursor, and you're gonna get a sequence, and that's where you're gonna write sequence and mask. That's, I'm gonna explain that. It's kind of it's not a modulo, but it works kind of the same, but I don't want to explain it because I don't know. So we set the payload to that, and then we're gonna unlock. So it's very important. This sequence is gonna be atomically loaded, but still writing. And I was wrapping my head why this happened. I couldn't understand it. That even if we have an atomically safe sequence, you're still going to have race conditions if you don't lock or protect the buffer. It's because mechanics of Golang, right? It's just unsafe. Nothing we can do about it. You could use some sleeping mechanisms. You could use some sleeping. I tested with. I spent basically a whole week with this bullshit. You could use some sleeping mechanisms, some longer spinning mechanisms each time you reserve. The problem is that it's going to be slow, right? We don't want that. If you want to sleep a millisecond, that's nasty because we are working with nanoseconds. I want to have nanoseconds. You know what I mean? So anyway, so let's basically test this with a mutex lock, right? And here we're gonna lock it here. If you want to read here, we're gonna write here. That's fine. I'm going to benchmark this real quick, right? So you're going to see. There's actually, wait. Why is this so fast? Unbuffer lock. How's going on? Yeah, the reason why I do this payload thingy, is so I have null allocations. It doesn't matter. Don't worry about it. Oh, I know what it is. Maybe. Did I have my race thingy? Ah, it's gone. Okay, cool, fine. Anyway. So let me try this. There's something is weird going on because I had a complete different result a couple hours ago. But hey, this is what it is. So this is this buffer. So let me do this with the atomic load, right? So what I'm doing here actually is not so long ago. Let me close this. Not so long ago in Golang, they added atomic store pointer, right? We didn't have that before. You had atomic store uint and all that shenanigans, add uint, but you couldn't store pointers. But now we can store pointers. So what I was doing, I was thinking, how can I do this? And I came up with this. Yeah. We basically store the pointer directly into the buffer. And it worked. Sometimes you just need to accept things. It is what it is. You see, and now we are basically at 23 nanoseconds operation, right? So it's faster. It's double as fast, right? It's actually three times faster. Yeah. It is what it is. All right. What is runtime GoChat? So runtime GoChat is basically you tell the scheduler that he can awake another Go routine. That's what it's doing. You need to be very careful with that, because if you overuse it or you use it at wrong places, you're gonna have performance problems, right? And I think there are very good videos on the internet or articles that explain runtime GoChat, but actually you don't need to actually know what it is. The only thing you need to know is that basically it's you tell the scheduler, go and schedule. That's what you're telling him. So you have a microservice written with Hollywood, and how does one communicate to another? What do you send to a channel that a service reads from? You communicate between actors by sending any message you want. Just for experiment, you can try naive spin lock instead of standard RW mutex. It could give some performance improvements. It is, but like I said, I'm very happy with this result right now. It gives me fast performance. This is 20. The thing is, I'm not quite sure. Let me try something real quick. Let me delete everything, right? I'm just gonna, basically what I'm gonna do is I'm gonna reserve and commit, and that's basically the LMAX. That's all LMAX stuff. Everything what you do with your data structure itself, with your buffer, that's your stuff. Of course, what I'm gonna do, I'm gonna wrap everything into an LMAX object that will do everything for us, right? But because if you check at Hollywood how I did it right now, it's the same approach, but it's not concurrent safe. Look at this consume. This is an optimization that I did, right? Look at this. It's super fast because instead of consuming them one by one, I basically consume the lower and the upper directly. And invoke it into my process. And then I do some stuff because it's a ring buffer. So sometimes we're basically at the maximum length of the ring buffer. And yeah, then we need to basically split them out and go back and all that stuff. It's nasty. But it works. The only problem is we cannot send messages in a Go routine, which is actually very important to do. That's why I am spending so much time. You could send a message in a Go routine, but you cannot repeatedly send messages in a Go routine, if you know what I mean. Right? How they are connected? They are connected with the engine itself. If you have internal, David, if you have internal processes, like processes that you use on your own machine, they are connected through the engine. It's like a routing mechanism. And if you have actors living on other machines, on other IP addresses, you use the remote, and it basically knows where to find it, and it uses DRPC with VT protobuffer or just protobuffer, or any serialization you want. That's an option I'm adding. It finds. I have a router and everything, and it knows. It knows the whole shebang. All right. So what I'm gonna do is I'm gonna try to implement this bad boy. But first of all, I'm gonna replace this one with the one that I had. That's what I'm gonna do. And first of all, I wanna test real quick something. Let's delete this bottleneck. We don't need this anymore. Let's delete this. Clean it up. Test consumer. That's fine. This benchmark can stay. Perfectly fine. This is good. This is good. Values. That was for testing, actually. I'm gonna test something real quick. Can I do something like... There are a lot of examples, David, in the folder. In the examples folder, where is it? Examples, whatever you want to call it. Here, remote, for example. This uses client and server, right? And you have a client, and you send the message hello to the server, and the server here is gonna read the message. Easy peasy chicken wheezy. Middleware. You can even have hooks. There is middleware. Look at this. What's going on here? This is wrong. This is bad. This needs to be deleted. Make a PR and delete this folder. The hooks, because hooks are in middleware right now. Anyway, it is what it is, right? First things first. I want to get this done because this whole queue thingy, which is basically the heart of the system, spent too long time on it. It's time to move on, because the next video I'm gonna make a TCP server with Hollywood. Right, we're gonna make a TCP server with Hollywood, and even if because I'm a GigaChat, I'm gonna use epoll and completely ignore Golang's net.com and just create it with system calls with the epoll stuff, and make our own event loop all with Hollywood. Later on. All right, so first of all, I'm gonna do some stuff. I'm gonna say it's gonna be N64. It's not quite sure if this is gonna work. So what's the payload? The payload is not this. Do I need pointers here? Can I not just store this? Of course, what is unsafe? If you're asking yourself, what is Unsafe.Pointer? Unsafe.Pointer is just a way to ignore Golang's type system. That's the only thing it is, right? It's no specific thing that will ignore garbage collection and all that stuff. It's just a way to, because if people talking about safe programming languages and unsafe programming languages, they're not talking about memory and stuff and cleaning memory, because of course, it's unsafe to not clean your memory, but I mean, it's also unsafe to drive through a red light. It's the whole tech community is, oh yeah, and Rust are people, basically blind people, handicapped people that cannot run without their parents. That's what Rust people are. C people are the real GigaChess because they know exactly what they need to do. But unsafe languages, they basically say that in C you can do a lot of unsafe stuff because you can basically trick and do some crazy stuff where you think you're going to have a string or a char or something and you're going to have completely different, right? And that's the same thing that Unsafe.Pointer does. It allows you to step away from Golang's type safety, right? Not quite sure what's going on here. Value slice int 64. Right. So this is this test consumer, right? So I have this one. I'm going to store this pointer. We don't need this anymore. This is not going to be foo. This is going to be this one. So let's first start without a go routine, right? So this is basically going to be synchronous. FMT println. Not quite sure if this is going to work. It's going to be N64 data. Like I said, guys, this is advanced Golang. You cannot find this on YouTube. This is the only stream. I know it's maybe boring, but hey, I'm so sorry. This is... Hey, it is what it is. What do you want me to do? Making some simple HTTP calls, JSON APIs and everything? Hey, I'm not going to waste my time anymore. You're not going to find it anymore on my channel. That's done. I have some videos about it. If you want to learn it, there are some videos. We're going to stop it. That's it. Playtime is over. It's completely gone. This is high value stuff. It's the difference between 80K. No, it's actually the difference. Can I say this? It's the difference between 50K and 200K. This is what I'm doing. That's the difference. It's what it is. And if you don't believe me, you don't. I don't care. It is what it is. All right, so we're gonna print this data. I hope it's gonna work because it could be that I'm actually... Damn, I got pointers, right? Pointers to N64s. Shit. That's not good. It's the same pointer. Let me see what the lower boundary. This benchmark, I'm gonna actually, to be honest, I'm gonna move it to down below. This fool, get him out of here. No mutex, no nothing. It's good, my friend. It's good. It's all good, my man. All right, so the lower boundary is fine, right? Lower boundary, it's working perfectly fine. These lower boundaries, it's all good. So we're gonna do this. We can't. I can't. How do I do that? I'm confused. Do I need to do that? Actually, what's data? Okay, that's gonna be, yeah. Because this is the unsafe pointer, right? Yeah. So now we need to cast, okay, we have a pointer, I understand. I see where it's going. So we need to say that this is a pointer to an N64 because it's an unsafe pointer. It could be a pointer to anything. That's why it's unsafe, right? It could be a pointer to, I don't know, to naked pictures, you know, some naked JPEG. We don't know, so we need to say that's an N64. And hey, this is, like I said, this is what you want. Hi Anthony, I only study Golang. I only just to start begin studying Golang, and your channel is very useful for me. So thank you for your content. Hey, it's a pleasure, man. Respect. I've been learning a lot through your full API REST case. That's it. So I have these full API stuff and JSON shenanigans. So you follow that, and then we can go step higher. You know what I mean? We grading up. First of all, I needed to spend some time warming everybody up, right? With simple videos. What's context? What's this? What's that? How to write Golang, structured project. Learning all that stuff to you, and now, boom. Now it's the real deal. Now we're taking over the space. We are the deviation, right? We are the deviation. I don't even post any videos anymore on our links on Reddit because we don't care anymore. Stack Overflow, we don't care anymore. Twitter, we actually don't care anymore. Let people do their thing. We do our thing. Our community, my community, our community, we are a deviation and we don't give a shit. You know what I mean? If we use uppercase constants, we use uppercase constants. You know what I mean? If we write everything in main, we write everything in main. It doesn't matter. The only thing that matters is that cigar and the margarita we sip on the beach. That's the only thing that matters. You know what I mean? It is what it is. Okay, that's fine. It's all good, what we have here. The problem is, how can I have my int? Yeah. What are we doing? What is this code? Something is wrong. Wait, that's not true because we store the address of this integer, but what's going on here? Yeah? Okay, I need some experts here in the field. It works with other types, but with what I'm doing right now is I don't know. Look at this. So we dereference a pointer, right? That's what we're doing, right? So like how can you translate this code? Well, it's very simple. We are casting this data to a pointer of int64. That's this. This will say, hey, this data is, I'm gonna cast this unsafe pointer, cast me this to a pointer of an int64. And then we say, yo, dereference this. But it's not working. No, it's not true, it's not true. No. We're printing this thing here, right? Man, what am I doing? Wait, I think it is working, but it's just... let me do... Okay, these iterations. Let me do some simple iterations, right? And look at the size of this buffer. It's like, what is this? This is like... this 128, it's like the first day at the gym. You're this. The first day at the gym. You're either 64 bytes or... Look at this. We are this. I'm this. 64. That's what I am. That's the size that I am. Alright, we're gonna do 10 iterations just for our brain. Shit! Look at this. This is garbage, right? Shit. I think I do something wrong. Wait, maybe it's already... Maybe we should do this. Pointers to int64s. That's why it's unsafe. We do pointers to int64s, right? Yeah, that's it. Because this is no... Yeah. Is it? Look at this, man. No type hints whatsoever. Everything is fine in this world of unsafe. Okay, it's not. Wait. Oh, yeah. Shit! I need an expert. Right now. I need a doctor. Medic! I'm bleeding. I'm bleeding tears. Okay, so... Fuck this thing. So we're gonna bring back foo to life. We're gonna bring back foo to life. Type foo. If there's problems, we use foo. It's crazy running... maybe it's... No. It's not. It's because... Roman. Maybe it's because you run loop, go routine, wait group. No, it's not. Because this is just... a simple loop. And I just say go, because then we can block on consume. And it just will loop synchronously here, right? Okay, so what are you gonna do? We bring back foo to life. It's simple as that. It's so simple because by the end of the day, we're not gonna use integers. We're gonna use this val and in64. Look at this, right? Again, foo. So that basically means that this thing, this value is to test. You're gonna see what I'm gonna do with it later on to test if our thing works. Do we need foo? Can we use a non-pointer foo? Let's use pointer foo, right? Pointer foo. This buffer is going to be of pointer foo, right? Pointer foo. Size pointer foo. I love the word. I love the word pointer foo. Pointer foo. Sounds so cool. All right. So what we're gonna do here? We're gonna make a foo here. And foo val y. That's what we're gonna do, right? Look at that. And then here, this stupid benchmark, I'm gonna comment this out because... All right, so now we're gonna test it again. So right now, we're gonna say, of course, look at this. This is why it's not safe, right? Look at this, what's gonna happen. Boom. This is so wrong. Guys, listen, this is not good. Don't believe it. Don't believe this. This is wrong. This is unsafe. Never do this at home. Never do this at home. So this is not gonna be this is gonna be a pointer of pointer foo val. All right. You see what's going on here? Now we're there. Now we're talking, right? Look at this. Now it's working perfectly fine, right? So we have consumed all of these numbers, right? We have 10 iterations. So it's going to be fine. It's going to be 10 messages, right? It could be whatever, right? It could be whatever you want. So let's use 100. Let's see what's going on here. Boom. It's going to be perfectly fine. Look at this. 100 beautiful messages. Okay, cool. That's fine. So we know that this is working, right? Wait, first of all, we're going to make a test for this, and then we're going to test it in a concurrent way, because that's why I'm doing this, is because it was not safe to use send in Hollywood in a Go routine, in multiple Go routines, because the buffer, the ring buffer was not protected, right? It's a very important lesson. This inbox, this buffer here, this ring buffer was not protected. And it uses the old Disruptor. It uses the old LMAX. Now we have our own LMAX. Right? Because we can. So. And then we're going to move this to Hollywood. And then we're going to see if everything works. Right? And that's it. And then I'm going to drink wine. And watch The Walking Dead. And hey. Repeat the process tomorrow. Right? Cool. Because I'm also gonna rewrite the decentralized poker engine in Hollywood, because that's the reason. Watch all these streams of a decentralized poker engine, and you're gonna see we run in so many distributed concurrent issues with all these messages coming asynchronously from all these players, and we are in trouble, and we made a table and our player list is borked, and then we need to re-implement the player list, and it's again borked, and then this thing is a mess. The decentralized poker engine was hard, and Hollywood is the savior. It's the messiah. It was the leader of Atlantis. You know what I mean? The hidden city, the lost species, the builders, the hunter-gatherers. The hunter-gatherers, man. I'm watching a documentary about the hunter-gatherers. It's unbelievable. They didn't know how to invent fire back in the day, but they were building like this massive structure that nobody can build in 2023. Can you imagine? Something is wrong with the world. Anyway. So how can we test this? So we're going to have these values here. So what we're gonna do in this test consumer, we're gonna say t values append t values. It's gonna be this foo. Of course, I'm gonna rename foo because that's not a good name for the test, right? Hey, I know what we could do. We could actually do this. Look at this. We could do a slice of int64, and then we're donezo, right? Okay. Like this, right? And then what we're gonna do after consume, where's this? That's for later on, that's for later on. That's sitting there for the next test. So we're gonna do this. We're gonna make the vals here. Vals are gonna be a slice of int64. We're gonna loop through all the consumer values. Then we're gonna say in slice. If we don't find this number, we're gonna append it here. So that basically means numbers. Actually, this represents messages. Messages we did not receive due to race conditions. Race conditions, right? Conditions. Right, so then we need to say each time this list here is not null, not 0. That basically means we have race conditions. So we're gonna print these values and we're gonna say a race condition. Right? That's what you're gonna do. It's that easy. Of course, there are no race conditions, right? Because we're gonna println. We're gonna print out the consumer values. And what's gonna be the consumer in Hollywood? The inbox, right? Now it's a test consumer. Like this simple thing that because a consumer, look at this, and I'm gonna show you. Always use interfaces. Consumer is an interface, right? Consumer is an interface. Consumes the lower and upper boundaries of the ring buffer. The only thing I provide to you is the lower and upper boundary of the ring buffer, and you can do with these boundaries whatever the fuck you want, right? And of course, now our consumer is this test consumer that we use to test the values. In Hollywood, that's going to be the inbox, if that makes sense. Are you familiar with GoFunct? It has some utilities like inslice contains. No, I'm not familiar, but I can imagine it's coming handy. It can come handy, that's for sure. That's for sure. This Nightbot, look at this. Join my Discord community if you're willing to learn more about blockchain development. That's true actually, but still, it's not. It's an old Nightbot message. All right, I'm gonna delete this. All right, so what we're gonna do is first let me print these things out. I'm pretty sure that my own implementation here is working. Boom. But so we have everything, right? We have 99 messages and no troubles. Perfectly fine. Okay, cool. So now what we're gonna do this. You go to settings, boom, buts, and you say -- race. Very important. Why? We want to test race conditions. If you're in VS Code, of course, right? Otherwise, you need to do go test, do something, do some crazy stuff like your tests and then min race, yada yada, right? So first of all, we're gonna say a weight group. Then we're gonna say VG add 1, go func, VG dom, do this, right? It's very simple. We're gonna spawn a go routine. Why? So we are out of the way. We are out of the way of, so we can block on consume, right? Consume is basic. Actually, that's a bad name. This should be a C run or C start or something, right? And later on, it's gonna be, you will see what we're gonna do, guys. Hey, you gonna see. All right. So we're gonna schedule this in another Go routine so we can block on consume, and then we're going to loop through the iterations, and then we're going to add one to the wait group. We're going to spawn a Go routine. We're going to basically encapsulate this iterator, otherwise you're going to have troubles. We're going to reserve one. We're going to get a sequence. We're going to store that shenanigans into our buffer. We're going to commit the sequence, and then we're going to say VG done. We're going to wait here, and then we're going to close the consumer. So this doesn't block. We're going to do our shenanigans, and then we're going to see if we are in harmony. I think VG add iterations would be... yeah, that's true, David. Actually, you're right. You have a point. You have a point. You could do... actually, to be honest, like this, right? We don't care. Iterations. Iterations, just like that. What's going on here? Int. Yeah, int, of course, because VG, you know, VG. He doesn't play the big game, right? He plays 4 bytes. We play 8 bytes. You know what I mean? Because memory is no problem anymore, right? These days. No, we use N64s because these upper boundaries. Why do we use N64s? Because if you use an int, you have 4 bytes, right? You can store a number up to 4 bytes, which is pretty large, but not large enough. Because if you have a long-running process, and you're doing a lot of messages, these upper boundaries, let me show you in LMAX. These, yeah. Where are we here? These, where the fuck is this? It's in cursor here. This cursor basically, it keeps incrementing, you know what I mean? So it needs to hold a big number, right? We want to be sure that, so that's why in N64, right? These days doesn't really matter, right? It doesn't really matter if you're using 4 bytes more than normally. Oh, hey, 2 cents. Who cares? You know what I mean? If you play the big game, the big money game, it doesn't matter, right? Okay. So we VG add here, then we do this, VG done, commit, yada yada, wait, close, consume, do our shenanigans. Let's see what's going on here. This is the moment, my dream. Wait. My dream is basically fell apart. I think there is a problem with this thing. My dream completely is broken. Again. God damn it. How is this possible? I don't even see any race conditions coming up. Look at this. It's completely safe. It's probably bad code that I wrote here. Or is it maybe... You know how it's gonna end up me using a mutex. I can already see it coming. I knew this in the beginning of the week. I was thinking to myself, Anthony, it's gonna end up using a mutex anyway. So what are you wasting all your time trying to figure this out? But I'm not gonna quit. I cannot imagine that this is not gonna work. I spent too many hours in it. I believe in the dream. Could it be that this is no, it's not, because we're writing. He doesn't matter. We're not reading from it unless we're already out of all that bullshit. Oh man, this is not true. How is this possible? Yeah, you can look for race conditions if you do this. If you use the race flag in your test, dash race, then it will find any fucking race condition there is. But now it doesn't. I can print the vals, but they are a lot, man. These are the vals that basically not... These vals are not the ones we are missing, right? Let's do... print... Is values as small caps, right? How is this? How can it not work? Now it's passing, you motherfucker. Oops. This code is This is yikes, man. Wait, let me print out these files real quick. Figuring out is like... Yeah, there is no 1582, there is no one. The dream is completely borked. Sometimes it passes and sometimes it's not. That sounds like a race condition to me, but it doesn't find a race con. It doesn't show me. Right? So what is this language? It's garbage because it knows that we are using an atomic store pointer, so it thinks it's all fine, but it isn't. But that doesn't mean that we are wrong. It could be that's a bad implementation of yeah, it's okay, wait. This cannot be true, man. Why is this? Look, what we could do is this, right? Let's forget the buffer. Let's forget that first. Let's forget this guy. Let's just think about the lower. Let's think about the lower here. Right? So we're gonna use this as a reference for later on. Let's say t values is gonna be append t values. Let's think about the lower. The lower is the lower boundary of our buffer. Right? It's very important. Let's think about that. We're going to append the lower boundary and see what's going on. So that's fine, right? So the LMAX implementation I did is fine. That's working. So all these consumer producer stuff is basically is concurrent safe. It's concurrent safe to get these boundaries of the buffer you need to adjust. Because I can do a lot of iterations here. For example, I hope it's safe, right? I mean, we never know. Let's say, what is this? 10,000. Let's do like that. It's maybe a little bit easier to read. So you see, this is going to be perfectly fine. It's working like a charm. It's blazingly fast. It's all good, right? I'm gonna do a lot of stuff, a lot of computation right now because we do a very bad check code, but it doesn't matter. Oh man, I'm so pissed, man. Ah, it's not gonna work. Oh, I'm so sad. This is... Cancel running test, please, because... Hello? There's a little bit too much iterations for my PC. But it works. Damn it. So that basically means that... atomic store pointer... It's a doc. All this cool stuff are implemented in the runtime, and we cannot access this bullshit. Where is the implementation of store pointer, please? Nobody knows where it is. Nobody. It's a magic black box nobody knows about. Okay, we're fine. It's just in the doc. Wait, so what's this data thing? An unsafe pointer. Okay. Wait, so how can this not work? I cannot believe this. It's atomically not that safe then. Are there any X specialists here? How many? Yeah. Yeah, but VG weight is not the... No. No. I know what you mean, but it isn't, right? Because this is the outer loop, This is an outer go loop. And that's basically to schedule this guy on another go routine. And we need to wait here and then close it. So this is a blocking call. Blocking call. This will block. Blocking call until close is called, right? That's what's going to happen. That's why we need to do that stuff. What we could do basically, but still, it's the nil pointer stuff we have here. That's very problematic, right? So what we could test also is let's play with Unsafe.Pointer, say. This can be gone. Well, this is already commented out. What an idiot. Data. It's gonna load me. I'm gonna cast. Why do we need to cast this? Okay, we can't. Okay, cool. That's why we need to cast it, because we cannot cast this to... We need to cast it to a pointer of an Unsafe.Pointer because it's gonna return us an unsafe pointer. That's so weird. Whoa. Huh? Okay, it is what it is. It's fine. So we do... I'm thinking about how it's working under the hood. So unsafe pointer. So what we actually say here is the buffer, right? Lower and mask is basically the location of our data, right? That's the location where we need to be. That's the value, right? That's the val. But we say this is unsafe, right? This code is unsafe because it's unsafe. Yeah, David, exactly. These race conditions, because we don't care about that. You need to think about it. It's too fast. Listen, there's something people don't understand. The race detector doesn't give us race condition warning. Normally, he's the first one. Look at this. This race condition, he sees everything. This guy is... look at this. So... Right, so what we're going to do is we're going to just access this thing. What is this? Consumer values. This is going to be, goddamn, there are pointers, right? We don't care about this anymore. So if we do this right now, probably some issues here. Yeah, there's going to be unsafe pointers. I know. You see, there is, boom. That directly, he is there. Like the police on the street. He is instantly there. So he's telling me, hey, amigo, look at this. Here. Unsafe, you read, and where do you write? Here. Yeah, this whole thing probably is going on here. Here's this, right? Something like that. So, but if we say, so even if we do this pointer stuff, that some values are not in our slice, we don't actually care about that, because in a networking environment or even in a computing environment, how fast are you going to send? Because you need to understand, we're looping through all these iterations here, right? And that basically means, so let's say these are, for example, 1,000 iterations. That means that you're going to spin up 1,000 Go routines at the speed of your CPU. That means it's going to spin them up as fast as your PC can spin them up, which will never happen in an application. This will happen in an application, right? This will happen in an application, right? Where you're gonna loop through some data and you're gonna massively send some messages at the speed of your CPU. But these Go routines, there is no need to do that, because calling send in Hollywood is an async, is a non-blocking operation. You know what I mean? Send is a non-blocking operation. Kinda a non-blocking operation, if you know what I mean. Because sending does not wait for a response from the actor, right? Sending is just sending the messages and call it a day. So you don't need to spin up Go routines for all these messages. So this is an unrealistic scenario. So what we could do, it is what it is. It's true, I swear to God. But what you need to do here is basically you need to give it some breathing room. Because you're never going to do this concurrency at the speed of CPU, which is, there is no time for it. It's like clock cycles is way too fast, but you know what I mean, right? So the only thing we could do if val wait, val is not, that's the dereference stuff, right? Let's see what's going on. Why it takes so much time? What's going on? How many iterations do we have? 10,000. You see, now it's fine. Now it's fine. You know what I mean? It's fine. Of course, it takes a millisecond. I understand. Nanosecond times 500. That's half a millisecond. Is that true? Not quite sure. No. Microsecond. I don't know. I don't know the order. I didn't went to school. I'm so sorry. Val is nil, which is so fucking weird. I don't understand why that is. What's faster, a micro or a milli? Milliscope. I know a microscope. I don't know a milliscope. 11 seconds. This is not gonna work, right? This nanosecond was already broken. Damn. Reading is faster than writing. Oh! Like... Wait, David, this could be, that could be it. Is that true? Nah, that's impossible. Wait. That basically means that we commit. Wait. Wait, I'm gonna keep some less iterations. I need to debug this because this is weird stuff coming on, right? So at 10. An unsafe pointer, can that be null? Oh man. How can I GD? I cannot find a definition for this. I just want to go into this definition. That's the only thing I want. It doesn't matter. So sometimes data is null. This is val. So this foo. So data is an unsafe pointer. We cast this unsafe pointer to a pointer of foo. That's what we're gonna do. But sometimes this is null. Sometimes the value is null. That's insane. What you could do is this. If it's null, the upper, we don't care about the fucking upper, right? Who cares about the upper? The lower boundary. How do you write that? This one? Lower boundary is this slash new line lower. Two less iterations. Do I sleep for something? Do I sleep here? Nanosecond, 5 milliseconds. No sleeping. The speed of CPU. Speed of CPU. That's. Hey, come on, man. Give me this error. Fucking bitch. Yeah, it's true. The value is null. But it can be, right? It could be that we are too fast. It could be that because we have this reserve here. The problem is this should be a blocking. So we say atomic store pointer, and then we commit. And then we basically already here consuming. So each time this guy commits, we are gonna consume because he commits the. If you do commit here, it basically gonna store the written, right? And the written is the upper boundary, right? The upper boundary, the lower boundary, excuse me. It's gonna be the lower boundary of the buffer, which is here. For lower, smaller than upper, consume me lower upper. And then we say current store upper, right? So we consume to upper, and then we say lower is upper. It is what it is. Classic stuff. And then this is some other stuff, right? We gate and we sleep just to make sure we don't consume the whole CPU when we are idling, right? So you need to understand that this consume, look at this, right? This is an interesting lesson we're going to learn here. We're going to debug here. This is crazy stuff, I'm going to lie. And I think we are fine. I think we are pretty safe. But I think the semantics of store pointer... Wait, I'm gonna say it what I mean in just a second. You see, each time we commit, we're gonna higher increment or upper boundary or lower boundary. And so we're gonna instantly consume them right here because we are already consuming here. It's already waiting, and I'm snap boom, and it's doing that. So does that mean that atomic store pointer is... Does that mean that each time we call this, we are not 100% guaranteed that our memory is being set? Is that the case? Because that would be nasty, right? Like I said, this is at the CPU speed. This will never happen in production. There's no computer programmer that is gonna call all these iterations and spin up all these Go routines because it won't happen. You don't do that. Of course, you do that in iteration. It could be that you're gonna send 10,000 messages to a process, but you're never gonna call 10,000 times a Go routine because send is already non-blocking. You know what I mean? It's already kind of async. But of course, and with a mutex is different because a mutex will lock eventually, right? It will literally lock. That's why it's slow. What up, Novan? We store a pointer. We could write this a little bit cleaner, right? We could say the PTR is going to be Unsafe.Pointer. I'm pretty sure this is perfectly fine. It's a little bit of thinking. We're going to say nBuffer. We're going to say the sequence we just committed and the mask. That's the pointer. So we're going to store Unsafe.Pointer this. Huh? Why is this an error? Expected one expression. Why? Wait. What the fuck is this? Huh? What did I do? What did I fucked up suddenly? What the fuck is going on? I'm not gonna touch it. I don't touch it anymore. It's fine. It's good. It's a long line. We don't care, right? Brackets are unbalanced. Ah, we're unbalanced. Okay, I see. Yeah, it's fine. It's good. Atomic store pointer. So could it be that storing this pointer takes more time under the hood than we commit here? So lower boundary 25. Wait, what we could do here is actually we could use a debugger. We could use a debugger. Yeah, of course, Anthony. Can you please, can you please put it before your log fatal, man? Please, come on. Hey. Yeah, no, if I did that is, but that's because I'm printing this buffer out, right? Don't worry about that. Okay, so what it's telling me here, lower boundary 8. That's where, wait. Lower boundary, fetching, buffer index, lower and mask. And this mask is basically, the mask is, its purpose is to make sure you don't have an index out of range. You're gonna ring, you're gonna circularly, it's like a modulo thing. That's maybe the best thing you can compare it with. But it's not the same as modulo, right? But it does the kind of, the principle of this thing is to make sure you are not going out of bounds. So give me, yes, okay, cool. So we are at bound 18. That's the buffer index. That's where we're gonna fetch it from. That's this one. $18. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It doesn't matter if I miscount it, it doesn't matter. There are enough. So yeah, it's a race condition, right? I mean, is it a race condition? I have no clue what it is, man. It's so weird. It's so weird behavior because now it's gonna print me this thing, all right? What is this? Of course, this race condition is because we printed out the buffer, right? Of course, we cannot do that. Let's use mutexes. Yeah, maybe. Why not? Do we need? Just gonna use a mutex. Fuck this thing. So what I want to know is basically, once we have this value is null, right? The problem is going to be that this is just a cost, right? So can I lock it here? So I'm locking here. So let me print out let me first of all, why is this buffer so fucking big? Let me make a small buffer. Maybe that's a little bit better. Let's do that. So we're gonna lock it here, and then of course we need to fucking lock this fucking buffer. That doesn't actually, I don't think it's gonna interfere. I don't think it's gonna interfere with. This needs to be outside of it, I think. Let me see what's going on. Alright, that's good. Of course, I'm still garbage. Good night, Ice Bear. It's like it doesn't matter. And I swear to God, we need to sleep here for a bit. What's going on here? This is so fucking frustrating, man. I don't understand why this is happening. It's even worse. But I think This is no problem. This doesn't matter, right? Don't be confused by these nil values. It's because you're getting this consume is getting called. It's because in a concurrent environment, we didn't set each time you call reserve, you don't know what it's going to be. How do I say this? It could be that we still need to set this in the future. That doesn't matter. But what cannot happen here is if we consume the lower, lower mask. You stupid lock, man. Fuck him. What we could do is this. Like I said, it's I don't know what it is, but this thing, guys, this is not what it tells you it's doing. But it's fine. It's fine. You just need to understand the mechanics, and this is very dangerous, but I know it's fine. One. So this store, look, now it's fine, right? Now it works perfectly fine. Look at this. Everything is fine. The problem is, this is nasty. The problem is that, like I said, first of all, you are never going to we tested. Where is our beautiful test code? This was our beautiful test code with the sync. This, yeah, I'm gonna reduce it, Fernando. We're gonna see how far we get it. Like, let me first. Let me copy this real quick, guys, because we need to test this. What's going on? I was gonna call this async. Right, so this is async, right? So for sync, what we're gonna do for sync basically is we don't need gofunc here, no time sleep, no VGs, no VG here, no this one, no wait, close here, block here. We can test it later on here if you want with these values. We're not gonna sleep, it's not needed. This is fine. We can have the same consumer, that's all good. I think it's gonna be fine. We tested this already, right? Sync kinda. Look at this. So sync is gonna be fine, right? Sync is going to be perfectly fine. We don't do anything, so we can actually... right, it's fine. Right. So in a synchronous environment, it's all good, right? You can call it at the speed of CPU. For some reason, that's fine. For some reason, it's completely fine. We tested that with messages, and we compared them and everything. It's fine. What you could do is maybe do a deep equal on the pointers and see if the same. Wait, let me quickly do that real quick. Can we do this? So it's going to be unsafe.points. Can we call deep equal to these guys here? But actually, we know that foo stores values, so we could do again the same shenanigans. So we have a good test, right? Because otherwise, we're going to shoot ourselves in the foot if we don't set this up right. So we have values here. We can append, right? Val, right? We can append these guys here. It's going to be slow, but I know it's going to be super slow. But it is what it is. In64 here, delete this here, do that. Okay, that one. What's going on here? Yeah, oh. Brackets, overrated, right? So what do we test here? We're gonna test this, right? We're gonna see if we don't receive anything. And so we're gonna check if there is some message we didn't receive, right? Could be a nil, but we check nil already. Otherwise, we're gonna have a dereference panic. So we're gonna check that. It's very non-optimized stuff, but it's just for now. Sync. So sync should be fine. Cannot use Unsafe.Pointer, yada yada. In64 stuff. Test new consumers. All right, that's the same thing. So let's do sync. Sync test is going to be fine, right? It's tested everything. All the messages are there. No problem. But in a Go routine, we also tested that the sequence, the reserve and the commit works perfectly fine in... So the LMAX implementation itself works perfectly fine, right? There is this. I tested this. It's all good. It's already running in Hollywood. It's working fine. Even I fixed it, so it's working concurrently also. The problem is this unsafe thingy with the buffer, okay? And you could say use mutex, yeah, but we are already 3 times faster, right? That's important. Can you imagine if you have a lot of iterations, right? Okay, so now we go to async. Async without sleep. I don't know why. Because these are 100% guaranteed to be unique. But for some reason, I think we already reading uncommitted memory. You see? We have a nil thingy. Do we do the same shenanigans here? No, we don't. Okay, I could actually use the same codes, but hey, it is what it is. I'm gonna fix it later on. You see, so we have a problem because we have a race condition also. So some value is not present, even though there is no null, right? But that's fine. Even if we do this time sleep here, even then with this time sleep above, so we give the Go routine some throttle before they're gonna do their stuff. That's gonna produce same errors. You see? Producing the same errors. Buffer problem, and then even though if we don't have a null value, but we have null values, more than ever actually, more than ever. But hey, if we Yeah. Harrison, links, tag me on Discord. No, Nightbot is too strict. Tag me on Nightbot. But if we do the sleep here, if we do the sleep between storing the pointer and committing, because that's important. Committing, each time we commit, it will, boom, it will instantly consume in this loop. And I think the problem is, for some reason, because we're in a Go routine, I don't know what's going on. I don't know what magic is going on. This store pointer here did not do his job already. Mom spaghetti. Knees weak. His arms are heavy. But if we sleep between these two, we give this atomic store pointer time to do it. Say, I have no clue what it is. It's garbage, right? That's fucking. It's. But yeah, we need to fix it. Then it's gonna work. I think. It's not. Now we have this problem. Wait a minute. I'm gonna check Discord soon, Harrison. The question is, are we already done? Are we already done consuming? Probably we do. Wait, is this correct? I'm just trying to some stuff out because this is not logic. I tested this. Because if I append, look at this. If I append a lower, that's what matters. If I append a lower, so we're only gonna test the lower. This is so weird, man. I'm so confused. I'm almost there. I'm pretty sure I'm almost there. It's just a small adjustment I need to do to make this thing work. Just something I need, some small caveat, some small big brain stuff that just is there, or maybe somebody that needs to shatter my dreams. Why? Please. Why is it? Why? Why doesn't? Oh, the sync. I'm clicking on sync. I'm the biggest idiot on the planet. This means that consume is not being called, and I tested this. What's going on? Golang. Let me see what's going on. Yeah, this is doc.go, but where is this function? This is just a function signature, right? That's basically getting under the hood. Pointer load. And less error prone. Pointer load! I'm completely getting. If you code for too long time and you're trying to debug some stuff, you get something weird happens in your mind and you get completely crazy. You know what I mean? And that's what happened right now. And my code is a mess. My whole test is a mess, and I have no clue what's going on anymore because I made a mess. And that's the point where you want to quit, guys. That's the point. We all been there. I've been there. You have been there, or you probably are. That's the point where you are basically a little bit demotivated. That's the point where you're going to quit. That's the point where you're going to stop doing your stuff, what you're doing. You're going to play a game, or you're going to be mad and sad, and you're going to be, and you're going to smile. It doesn't matter because this is already advanced stuff. We don't care. Like 99% of the people have no clue what is going on and will never know what is going on and will never solve these problems, will never read these problems. They run away from that kind of stuff, right? So that's the first thing you need to already put into your brain. Like, you're already doing stuff nobody else is doing. That's the first thing. So you're already, first of all, if you want to do stuff that nobody else is doing, everybody's using mutexes and yada yada and channels, and if you want to think outside of the box and try to explore for creative solutions, there is nobody that's going to stop you. But you need to understand that if you're doing that, it's not going to come, right? Because everybody would use these techniques, right? If you want to not invent, but if you want to try to combine different kind of techniques, you will run across problems that you need to solve. And now I need to figure out what's going on and what kind of the program is working and all that stuff. Wrecked by my own code. It is what it is. Slapped on the cheeks. And that's where a lot of people stop, right? A lot of people stop where it's getting hard. It's the same thing in life, in the gym or whatever. Once it's getting hard, you're going to stop and you're going to try something else that gives you quick, cheap dopamine. But I don't believe this. I'm not done. I'm not done yet with this thing. I'm legit not done. This is not the end. I'm going to break it up into smaller parts. That's what I need to do because... So, because look at this async test right now, right? So, let's say let's rate his sleep real quick. Yeah, value is null. Of course, it's null because we don't push it. Hey, hey, you don't push it. Sync. Here, consume. So we're not going to play the data game real quick. We know that's a problem. But first of all, we need to be 100% sure that lower upper is not going to fuck us over. So the only thing we're going to do is append lower to the values. It basically means that if we do that, we should have basically 1,000 lowers, isn't it? 1,000 incrementations of a lower value, of the lower boundary of our buffer. Because we have iterations here, constant, 1,000. 1,000. Man, I'm gonna be so happy if I can close my editor today. It's done, man. I have too much bytes, man. Too much debugging. Wait, no, we don't store anything. This is async. We don't store it. We're only gonna reserve and commit and call it done. That's the only thing we're gonna do. Boom. And we are not hitting the threshold. We don't not hit the iterations, I mean. Let's do 10. Oh man, I'm so fucking... Atomic value is completely broken. Atomic value is broken. That's what I can see. Atomic value is garbage. Never use it again. Atomic value. Atomic bullshit! It doesn't work! It doesn't work in Go routines. Atomic values. I need an I need a doctor, I swear to God. I need Dr. Go. Where is Dr. Go? Hey, call him. He needs to come right now. I need Dr. Go. It's not Dr. Go, I need fucking specialist. Specialist Dr. Go with 20,000 medals of honors. I'm gonna... This test set is in my way. Get him out of here. Get this guy out of here. So if I create 2 Go routines and create a shared buffer, one will produce and other one is consumed, produces... Yeah, normally... Yeah, exactly. That's what you need to do. That's what you need to do if you want to reproduce this, I think. But something is wrong with these lower boundaries here. Can I do an FMT? Oh man, hey, this is... LMAX my fucking ass. Just use a mutex and call it a day. It's so simple. Use a mutex, correction, use a bottleneck, and call it a day. Sip margaritas and smoke a cigar on the beach. Hey, and everybody that needs to... The application is slow. Nobody's gonna benchmark it. Nobody's gonna note it. Just say it's the fastest of the world. It's the fastest of the world. And everybody's gonna believe you. And you take the money and set margaritas on the beach. But no, we are not that. We gonna produce this. We're gonna say, what am I doing here? I'm completely fried. D. We're gonna say the lower is gonna be the D, and then the upper is gonna be the D also, right? Lower. Pretty sure this is actually. And the race detector, by the way, guys, race detector, where is he? I think he's sleeping. The race detector is completely sleeping. He doesn't play the game anymore, right? Where is settings here? Here, race detector. He's gone. He's already sipping margaritas on the beach. He had enough, right? That's what race detector do. You see, oh, atomic. Oh, mutex, atomic. It's fine. Bye, I'm out of here. And all the problems that comes after, he doesn't care anymore, right? He's gone. He's out of there. That's what as atomic do. The race detector does, right? At a certain level of programming, the race detector, you cannot rely on it anymore. You know what I mean? And I hope some specialists watch the stream overnight and come tomorrow with a PR or a mailbox or put something on Discord with the solution. I hope that. Maybe Rob Pike needs to explain what is going on, because this is not normal. This is witchcraft. We don't append anything anymore. It's done. It's fine. It's fine. The lower is 0 and the upper is 9. It's all fine. It's a bit confusing, but it's all fine. This is also fine, right? So it calls 2x consume. It's fine. We call 2x consume. And the first time it gives us the lower 0 and the upper 8. So we can grab 0 to 8 from the buffer, right? And then it's going to grab us 9. It's going to give us lower 9, upper 9. So we know we need to grab the last one out of the 10 long buffer. It's perfectly fine. This is equilibrium. All planets are aligned. It's fine. It's all good, right? Nobody's in problem. There are no tears yet. It's fine. It's perfectly fine. Now he split it up in 3 times because, hey, it is what it is. 0 to 4, 5 to 8, and 9. 10, all good. Race detector sees atomic and just skips the check. Well, I don't know, man. It feels like that, to be honest. Like, oh, atomic, and he's gone, right? And it's completely gone. The test is not passing, by the way. It's not passed, but it's not passing, right? It's not passing. This is not fine because it's 9 and we don't do 9, right? We do 10 iterations. You know what I mean? It's like it's this close, man. It's this fucking close. I know what it is. 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 I hope. That's me, right? That's like, I think I know what it is. And then I'm so hyped. And the tears almost from happiness almost come out of my eyes. And then I try it, and then it doesn't work. And that's the moment I completely freak out and just, I'm out. I'm just peacing out. And then it's done. Then I'm done for the day, right? And it's completely done. Then I'm done. And my whole evening is completely trashed. It's completely gone. I'm not the best person anymore in that evening. My GF, my friends, they are fucked. Because I'm a legit, uncontrol... You know what I want to mean. What I want to say. You see, I cannot even talk, but it's bullshit. I think I'm coding for 12 or 13 hours today. It's insane. I coded the whole morning for my job and now and then the whole afternoon for this bullshit. Time.sleep. That's not true, right? We're going to say time. I'm going to wait a couple seconds here. You know what's the problem? I'm going to explain you. Nobody sees this, of course. Thanks for not helping me. Look at this. We're gonna wait 2 seconds is fine. 2 seconds is already fine. It doesn't even matter. This time.sleep doesn't even matter. It matters, but it's just for now that it matters. It's nothing to do to enhance the code or something or to fix a problem. No, this time.sleep is just because we need. Look at this. No, it's not fixed. Oh, wait. No, it didn't fix it. I thought this this close was a problem. Even if the WG was done. This WG wait doesn't even matter anymore. Wait. We're blocking here, right? So we need to do... Oh, man. I'm going to say time after func. Time second times 2. Func. WG wait. I'm gonna get fired, man. I'm gonna get so fired. This is crazy. But wait, this is just for testing. So WG wait. C close. Because otherwise you're gonna block. That's what we're gonna do. It's gonna be so annoying to test. I don't think it's working. You see, it's 9. I have nothing to say. I have nothing to say anymore. I'm completely out of options. All the tricks of the trade are done. The cards are drawn. You know what I mean? Game's lost. We need to take the D once again. Sometimes you need to take the D. That's part of life. You know what I mean? Live on stream. Failing. The undisputed. Lost. Defeated. Broken. Humbled. That's maybe the best thing. Humbled. The undisputed. Humbled. Humbled by Unsafe.Pointer. No, it's humbled by his own shenanigans. I have music, by the way. You guys don't, but I have music. Because, yeah. Yeah, Harrison, I was thinking the same thing. I'm thinking the same thing as you, man. We have the same thinkings. But to be honest, at this point, everything could be like... it could be the for loop. It could be this for statement. That's what I'm thinking about. It could be maybe these brackets. Maybe these two parentheses. Maybe the compiler. I don't know. It could be maybe this comment here. Produce stuff. Maybe that's is doing something behind the scenes. I don't know what it is. Maybe it's some hidden code somewhere. Who knows? Everything could be the problem. That's the case. I'm just thinking the same thing, that maybe it's the coroutine and something the consume, because this is not. You need to understand that this test is not a real life setup. This is never going to happen in Hollywood. In production, it's not gonna happen like this. But still, you want, before you implement it, you want some kind of a test that basically confirms your implementation. I mean, that's what I think. With a mutex would already, with bottleneck, it would already been solved, right? With the bottleneck, you know what I mean? But that's the easy way. We don't do the easy way. We go the fast way. You know what I mean? We do the fast way. Wait, so this consumer values we don't care about. Maybe we do. The problem is, we're gonna say time. I don't actually care how I'm gonna do it. I'm gonna say time sleep. I don't. Wait, maybe we could do a wait by the way. So it's fine. Could do VG wait here. Not quite sure if the VG is done. Is already is enough. I don't know if the VG is enough, right? VG. Okay. The race detector is back. That's good. Yeah, okay. Yeah, man. Consumer values. I know, man. It's fine. We don't care. We don't care about the consumer values, my man. We care, actually. We have the uppers, right? It doesn't matter. We have upper lower here. It's fine. That's the only thing we need to check it out. This is not what we want. This is till 7. Right? We need to 10. This is also not good. We need to have till 9, right? Oh, this is so annoying. That's so asynchronous, man. This VG wait is not enough, man. Wait. This close, it doesn't matter. It doesn't even matter. I think it's just fucked. I need to. It's just bad. I don't understand why. Because everything is atomically done. Time.sleep, man. I can't even type anymore. It's time second, by the way. I'm gonna call it a day. I'm done. This is working, yeah. Working, yeah. Wait, what we could do is... This VG is not done because it could be that we are still consuming, even though this is done. It's still busy. So this is not correct. This VG wait. So that's why I did a time sleep. So we have some more time to get everything consumed. It's bad. This is bad. You see, it's like 8. It needs to be 10, right? For some reason. The VG weight is semantically correct. No, the VG weight doesn't is like us. You're right, Harrison. This VG weight is useless, completely useless right now because this consume is here. It gives me the same problems, right? If the consume, the cleanest approach is to block on consume and then just close when you're done. That's super clean. What we had before. But yeah, I'm so desperate that I'm trying everything to see. In the hope it will magically fix itself. Sometimes it happens. Sometimes you win the lottery in programming, and that's when you move stuff and suddenly it fixes itself. But in this case, it's not. So the problem is that that's also why we don't have these values, is because we, for some reason, we don't. Maybe somebody finds can spot the bug. I don't know. We loop 10 times. We spin up 10 Go routines, but we don't. We commit the sequence that we get, but we don't get 10, a range of 10. Consumer is reading ahead and writer is writing behind. Consumer cannot read. Look, the reading is this very simple implementation, by the way. And I actually also need to go very, very soon, but I still have time to show you this, LMAX. Because look at this, I'm using atomic ints every fucking where. Store. Wait, where is it? Something is wrong with this thing. This one. I think writing, to be honest, I think making a simple ring buffer, right? Just a ring buffer, like we know it. And we use atomic store, and we use atomic load pointers, and we just don't do all this consuming positions. We just make a simple ring buffer, but instead of a mutex, we use atomic store. I think it could also work. So this is what we do, right? So if we start, each time we start consume, right? So what we do is we wrote the current, which is basically our lower. We increment the lower. We fetch the upstream, which is basically... The upstream is actually also... It's also the written. I mean, it works perfectly fine in a synchronous environment. I mean, if you don't call it in Go routines, it works amazingly well. I mean, it works perfectly fine if you call it in Go routines, but you give it some time. Right? If you say time, sleep, time second, milliseconds even, it's going to work perfectly fine. I'm pretty sure about that. You see, 9 is what we need. The upper needs to be 9. Works perfectly fine. So you can call it concurrently. But for some reason, if you are too fast, we have problems. Pretty sure I'm fixing the reason why this stored pointer is not the problem, right? The stored problem was not the pointer. It's not a race condition. It's basically, I think it's a broken implementation. I think it races itself without. I need to like I said, I copied this code also. So hey, oh man, oh, I'm getting wrecked by open source. I'm getting wrecked by this guy. What is his name? Because look at this. Wait, let me. Oh, it's gone. I rebooted my PC. Damn. Is consume lower upper, where lower can be equal to upper semantically weird? No, because let's say you have a buffer, if you have a queue and you pushed 10, so you have a lower of 0 and a upper of 10, right? So it basically means you're written at 10, but you're reading at the lower. You read at the lower, which is 0. So if you read 10, you're basically even. So that basically means that the queue is at equilibrium. You have 10 read, 10 written, but also 10 read. You have 10 produced and 10 consumed. So your upper and lower are at the same. If you know what I mean? That's how you need to think about it. Holy shit. Okay, I'm gonna... man, it's like a whole fucking day once again on this bullshit, man. It's crazy. It never stops. I wanna do other stuff. I wanna implement other stuff. I wanna enhance other cool stuff on Hollywood. Not this stupid fucking queue, man. I just could copy another queue, but I don't want to because I want to be faster. And I will not sleep until that's done. It's already faster. It has some semantic problems with oh man, I need to go. My girlfriend is coming to pick me up in a couple of things, but and I'm still I'm smelling like shit. That's crazy. But hey, like I said, time is money. The show must go on. You know what I mean? I will treat her good when the time has come, when the time is ripe. Wait, what you could do is I don't know what we could do. We could do some logging real quick. So actually, what's the problem? It's probably commit. And these things, written, I need to. I'm gonna. How do you clear the queue? I have not. I need to, that's something, we need to implement that here, right, if you want. Yeah. I need more iterations because are we sleeping? Yeah, we're sleeping here, but it shouldn't matter. It shouldn't matter sleeping. This is an excuse. Sleeping here, you need to give the computer time. You need to give them time. It's excuses. There are excuses. Why would it be? I mean, it's a fucking computer. It can be as fast as itself, right? I mean, how can you? It's like I cannot go faster than myself at the same time. You know what I mean? So excuses. I don't need to sleep. So excuses are being made. We committed 19. Yeah, it's 20 loops, right? Okay, we're committing 18 here, right? We're committing 18 here. That's not good because we have 20 iterations, so we don't commit. So what is the problem here? Although we're 100% sure we're committing here, right? Isn't that? Are we sleeping here 10 seconds? And we're waiting here. What is going on? This is dirty, man. This is like a minefield, man. This is the bomb squad needs to. This is crazy. Man, I'm 2.5 hours. My camera can basically bork because he's overheated. He's not used to stream that long, and I actually need to go away, but I want to fix it. It's a dilemma. It's a double-sided sword. Knife or sword. It's fine. It's both dangerous. So we are 100% sure we're calling this. But we're not. What's going on? N64 to int conversion. Fernando is in the same thing. He's seeing ghosts everywhere also. He's like, oh, maybe it's the int conversion. I don't know, man. It could be anything. Like I said, it could be anything. Like I would say the same. Maybe it's the int conversion. I don't know. This int to 64, probably not. But it doesn't matter, right? I mean, if this is the problem, then I will never write this language in my life. Lock reserve to, well, that I was thinking. But the thing is, this is not logical, right? So we have print committing val. But we are committing here all the time. But we don't see it. We don't see it. We don't see it coming. We don't see this. What's going on? Are we blocking on reserve? Is that it? Is our reserve? Look at this, guys. So, again, my eyes are crying. I'm crying again from happiness because I think I found a problem. And then I gonna get another smack on the cheeks. That's not true. I think what's the problem is I think reserve is hanging. I think reserve is hanging. So this is fine. I'm gonna show. This is wrong. This is 18. It needs to be 19. I think reserve is hanging. I think, look at this, reserve. Here, we are in reserve, right? Look at this. FMT println spinning. My head. I don't know this song anymore. Spinning. It's spinning round and round. Okay, no, it's not spinning. It cannot be spinning. I think it's blocking for some reason. I don't know what it is. It could be it. It's not. It's not spinning. Fuck this spin, man. What is this code anyway? I think 1 second is already fine. I mean, it takes too long. Where is 19? Where is 19? Can somebody explain me where this lock producer commit here? Where is this? Where is this lock? It's not being found. It's not being seen. Yeah, I know increase iterations, but then maybe where is it? Shit, 5 minutes. I have 5 minutes. This commit is not getting triggered because we don't see it here. Store function is just it just loads stuff. This is just padding. That's not the point. It doesn't matter if the value is wrong, guys. It's not a matter if this sec, this reserve, this y, it doesn't matter what that value is. The matter is that this commit, this lock, is not getting called. You know what I mean? This log here, this committing is not getting called. It's not getting called. Nobody's calling it. So something is wrong. It's need to block, or this function just disappears like the Illuminati. I don't know what it is. I will debug it tomorrow, but now I need to go. Thanks very much for this stream. I'm so sorry. Actually, it was a fun stream. A little bit of debugging here and there. I cried 2 times. And yeah, this is what it is. Okay, guys, thanks for watching. Consider subscribing. Give me a thumbs up. Leave some questions in the comments. Jump to Discord. Yada, 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 yada. Look my Patreon. Fork. Star. Hollywood and all that stuff, and I hope you have a very good Saturday evening, and I see you if I